All right, I'm going to try using this new app to do this. So hopefully it works. If it doesn't, I apologize, but we're gonna give it a shot. So this is the linear inequalities, lesson 4.1a, and we're gonna do some notes together and a couple of examples. So a linear inequality is slightly different from an equation, not slightly, it's quite a bit different, because an inequality can have lots of different answers. When we have an equation, we put in one value, x equals 6, and if 3x plus 2 equals y, well, 3 times 6 plus 2 would equal to 20, right? So we had one input, we only get one answer, but an inequality can have lots of different answers. So we have a couple different versions. So a relationship between two linear expressions in which one expression is less than, right? Less than, my cat is joining in. We could have greater than. We could have less than or equal to. Less than or equal, right? We include that equals sign, or that line that's an equal sign underneath. Or we could have greater than or equal to. Now, the way that I was always reminded how to do this is we treat this little thing as a crocodile, right? Crocodile. The crocodile is very hungry. He always eats the larger number. So if we have 3 and 6, we would say the crocodile opens his mouth towards the 6 because 6 is greater than 3. So if you're trying to remember which direction the inequality opens towards, it always opens towards the larger thing. Okay, so that's review from grade 10 and grade 9, but obviously worth doing as well. So if we continue on, we have a solution set. So whereas with, we already talked about how with, with equations, we have one possible solution. Hopefully that's showing up, one possible solution. With a inequality, we could have multiple possible solutions, technically probably infinite possible solutions. So a solution set is the set of, set of all possible solutions. Right, set of all possible solutions. And we check if a point is a solution by substitution. Okay, so we can check whether a point is a solution by substituting it. So you've got a couple of examples here. So I'll do the first one and then you should pause for a second, try the others on your own. So we're going to check if the point 3 and 1 is a solution for the inequalities. So this is the point we're going to use, and we're just going to substitute those values in to, this is your x. This is your x. This is your y. We're going to substitute them in and see if they are a possible solution. So I'll do the first one. So we've got 13 minus 3 times 3 greater than 4 times 1. So let's just do the math, right? We've got 13 minus 9 greater than 4, 4 greater than 4. And we ask ourselves, is 4 greater than 4? 4 is not greater than 4. So this is not a possible solution because 4 is not greater than 4. And that's where things like the greater than equals to, right? The greater than equals to, less than equals to is important, right? Because if it was 4, is 4 greater than or equal to 4, we could say it's true. But it's asking specifically if 4 is greater than 4, which it is not. So take a moment. You should pause this, and you should try doing the same thing. Substitute 3 and 1 into each of these inequalities and see if it is a possible solution. And I just realized that for D, it did not translate when I did the student copy. So I guess we're just going to not do D. That's okay. Actually, I bet you I know exactly what it is. I bet you is y greater than or equal to 9, because the French translation loves to think of y as and. Anyways, so we'll do that one. So pause now and try the other ones on your own. Okay, so hopefully you've taken an opportunity to try these out. So I'm just going to quickly go through these. So in this one, we substitute in 3 and a 1, and we get 2 times 1 minus 5 less than or equal to 3. 2 minus 5 less than or equal to 3. Is negative 3 less than or equal to 3? Yes, it totally is. So that is a possible solution. In this one, we have y plus x is less than 10. 3 plus 1 less than 10. Is 4 less than 10? It totally is. So that's a possible solution. And then lastly, we have, well, I would assume y greater than or equal to 9. Is 1 greater than or equal to 9? No, 1 is obviously not greater than or equal to 9. So that is not a possible solution. So that's the thing, is you can check individual solutions pretty quickly, but the problem is that this method of verifying is not really effective if you want to check a bunch of points, right? We'd have to check them all individually, and it would take a lot of time. So we want to use a graphical representation, basically drawing a graph, to check a solution set of one or more inequalities. So eventually we're going to get to situations where we have multiple inequalities and we have to check them all, which can be very annoying if you want to have to do them individually using the method above, but with a graph, it's actually quite straightforward. We'll get to that in a little bit, but for now, we're just going to keep going with individual inequalities. So we're on to page 2. Oops. Got to figure out how to lock my page. Okay, so we're on to page 2. When a linear inequality in two variables is graphed, the boundary divides the Cartesian plane into two halves. So remember, the Cartesian plane is like our, classic, x, y graph, right? That we call out the Cartesian plane. So a half plane is the region. Man, this is a very thick point. Let's see if we can get that smaller. The region on one side of a linear relationship. Linear relationship. And 1/2 represents your solutions. So if we think about our sort of classic, graph where we've got, like I said, we've got our Cartesian plane up here. Normally we'd think of our graph as being like, oh, here's our line. Those are our solutions, right? For every x, there's one y. But in a inequality, we could have many possible solutions. So the idea is that a half plane is that half, right? It's always going to be cut in half. So there'll be one side of the Cartesian plane that are all your possible solutions, one side of your Cartesian plane that are not, those are not your solutions. Okay, so we call that area where all of our possible solutions are our solution region. So a solution region is represents our solution. Represents our solution set. So there's lots of different possible solutions, and these are all of our possible solutions. And something that's worth noting for graphing, if the inequality has less than equal to or greater than equal to, right? If they include the thing, we use a solid line. sort of like what I did up here, solid line. But if it uses a less than equal to, greater than or equal to, we use a dotted line or a dashed line, whatever. So as an example, if the thing up here was less than or equal to, greater than, or sorry, less than or greater than, not less than or greater than equal to, we would do the following. So here's my x, there's my y, and I would use a dashed line. That's just, you know, some mathematician decided that's how we're going to represent it. So they could have the same solution region, but the idea is that this graph would include the points on the line. This graph would not include the points on the line. And we just use the dashed line to represent that. So if we're going to graph a linear inequality, we have to do a couple things. First thing we're going to do is we're going to find the terminal, call it the terminal, which that's just the line or the equation line. Right? So, you know, y equals 3x plus 7, y equals negative 2x minus 4, whatever. So we're going to use the equation line. And we already talked about find the terminal and graph it. And we already talked up above about how if it uses less than or equal to, greater than or equal to, we're going to use a solid line. Solid line. And if it uses just less than or greater than, we're going to use a dashed line. So we basically graph the line as we would normally, but we just pay attention to whether or not we're going to use a solid line or a dashed line. After that, we have to determine which half represents our solution set. So second step, we're going to determine which half is our solution set. So we can always check. We can check by choosing a test point in the region and and verify it as a solution. Verify if it is a solution. Like we did on the previous page, right? So the idea is that we would want to choose a point well in the region. So again, if I'm looking up here at this example, I would choose any random point in the region, well, either region, because the idea is we maybe don't technically know, but we choose a point in the region and test to see if it is a solution. If it is, then that's the side that we shade. If it isn't, we don't shade it. Now, a useful point, a point that you would probably want to use, if at all possible, is 0, 0. 0, 0 results in some easy math. So if it's obvious that if 0, 0 is like in one of the two regions, use it because it's very easy. If it's not, you might have to use a different one. But if you can use 0, 0, it just makes things easier. And then we shade the region that is the solution set. So if you did that test point and you found it was the region, it was a correct solution, well, you shade that half. If you did a test point and you found it was not the region, then you would not shade that half. We'll do some examples. I think you'll see pretty quickly what I'm going for. So I'm going to the next page. So there are two, and then once again, I am rotating my camera. Give me a second. Okay, continuing. So there are two methods for plotting a linear inequality. The method to use depends on the form in which the inequality is written. I would honestly say that this is all just kind of one method, but I mean, whatever. So what we always want to do basically is we always want to rearrange the inequality so that it is in slope-intercept form. So, right, in this case, we've got negative 2x plus 5y greater than or equal to 10. So I want to rearrange it so that I'm in y greater than or equal to mx plus b, right? Our classic sort of slope-intercept form. I guess this could also be less than or equal to, whatever. But that's the thing we're going to do because then that'll allow us to graph it, okay? So I'm going to take negative 2x plus, I'll make that a little neater, negative 2x plus 5y greater than or equal to 10. I just rewrote it. So now I'm going to do the algebra that we have to do in order to rearrange it. So I'm going to start by adding 2x. I am operating under the assumption that you all know how to do this because this is grade 10 stuff, okay? So if you are not sure how to rearrange equations, actually this is grade 9 stuff to be honest, then you need to talk to me, okay? So add 2x to both sides. So we end up with 5y greater than or equal to 2x plus 10. I'm going to divide by 5. And I end up with y greater than or equal to 2/5 x plus 2, okay? So that's our inequality in slope-intercept form. Okay, so now I can graph this. So remember that we've got two parts of our inequality, or our equation, whichever you're using, but in this case we're using inequalities. We've got our y-intercept, we've got our slope, okay? So that's my y-intercept there. I'm going to start by marking it on my graph. So my y-intercept is 2. Okay, and our slope is 2/5. So we're going to count up to a rise of 2 and a run of 5. So, right, remember that our slope, right, is of the form change in y over change in x, okay? So we have a rise of 2, so we're going to go up by 2, 1, 2, and then we're going to go over by 5, 1, 2, 3, 4, 5. So I'm going to make a point there. 1, 2, 3, 4, 5. Okay? So I've got 2 points. You are going to use a ruler. I don't know how to do a straight line on this thing, so I'm going to just do my best, but you're going to use a ruler. I'll even actually do a point backwards just to make sure that I've got it kind of semi-right. 1, 2, 3, 4, 5. Okay, so you're going to use a ruler, but I'm going to just try to freestyle this because I'm using my iPad. Okay, and the reason that we're using a solid line is because we have greater than or equal to. Because we have that equals to there, we're going to use a solid line. All right. So we've got our solid line, we've got our terminal line drawn. Now we have to figure out which half of this inequality or of this plane we're going to shade. It could be up here, it could be down here. We don't know. All right. So I can clearly see that 0, 0 is in one of the planes, right? If it was kind of like right on the line, I probably wouldn't want to use it, but it's clearly well within this plane down here. So I'm going to use 0, 0 because it makes the math quite easy. All right, so I'm going to take my y greater than or equal to 2/5 x plus 2, and I'm going to substitute in 0, 0. So I've got 0 is greater than or equal to 2/5 0 plus 2. So then I have 0 greater than or equal to 0 plus 2, 0 greater than or equal to 2. Is 0 greater than or equal to 2? It is clearly not. So that means that this section here that 0, 0 is in is not the solution region. So instead, I'm going to shade Ooh, what's going on here? I'm going to shade, sorry, my screen is attempting to select everything. Whoa, don't want to do that. I'm going to shade the upper region because I determined that this lower region was not the solution region. So I'm going to shade the upper region. All right? I'm being a little bit sloppy here, but you get the idea, right? Because we determined 0, 0 was not a solution, so I want to make sure that I shade the other region. All right, so we've got two other examples here. We've got slope-intercept form down here. Draw the solution. This one's already in slope-intercept form. 3/5 x minus 3 is greater than y. So that one's already in slope-intercept form. And on the next page, there's another one that's also that you will have to as well rearrange. So I'm going to do those examples. You should try them on your own and take a look. They will not be in the video. They will be, actually, maybe they will be in the video. It's been a while since I've used this program, so I can't remember if it includes that in the video or not. But either way, I'm going to upload the PDF as well. So just try this out. Try method 2, method 3 examples out. See if you can get the correct graph drawn and the correct solution shaded. And then that'll be it for this lesson, and you should move on to the assignment, which the sub will tell you what to do.